We deployed our model to an Android app using TensorFlow Lite. Let's have a demonstration of this Android app. Let me search a bird, say blue jay. Go to images. This is blue jay. Let's check with our Android app. It can detect or not. You can see it shows 99.4 score that it is a blue jay.
My name is Kumar. Came long way here to do internship in Bennett University through leadingindia.ai. We have done our project on bird identification from minimal sample. The main motto of this project is to identify the bird so that which can avoid collision between bird and aircraft. Nowadays we heard that the bird strike has a great impact on aircraft, so it causes damages of millions of dollars. So let me give a brief idea about my project. Our project basically works on transfer learning, and to get a better accuracy, we test the dataset on a different models.
On this dataset, we use transfer learning and try with different model like VGG16, VGG19, ASCENT 15 and MobileNet etc. As we do not have much data for individual species of bird, so it is very difficult to get better validation accuracy. After experimenting with different model, we found that MobileNet V2 we had some better result for training accuracy and validation accuracy. Highest accuracy achieved 83% with MobileNet V2 after fine-tuning our model.
The very first step for training a model is to collect data. We use Caltech-UCSD verse 2011 dataset for training our model. The Caltech-UCSD verse 2011 dataset has 200 categories for words, which include 11,788 total images, around 65 to 75 images per category of words. As transfer learning is the most used methodology in deep learning, we use MobileNet V2 architecture for training our model. MobileNet V2 is most suitable for mobile and embedded devices. Best vision application where there is a lack of computational power. The MobileNet V2 is high speed, good performance and low maintenance deep learning architecture. The MobileNet V2 has 30-layer architecture.
Let's talk about implementation of MobileNet version 2. We created the base model from the MobileNet V2 developed at Google and pre-trained on the ImageNet dataset, a large dataset of 1.4 million images and 1000 classes of web images. First, pick the intermediate layer of MobileNet V2 will be used for feature extraction. A common practice is used to the output of very last layer before the flatten operation, that so-called bottleneck layer. The reasoning is here: the following fully connected layers will be too specialized to the task the network was trained on, and thus the feature learned by these layers won't be very useful for new tasks. The bottleneck feature, however, retain much generality. Let's instead an MobileNet V2 model preloaded with weights trained by an ImageNet. By specifying the include top is equals to false argument, we can load a network that doesn't include the classification layers at the top, which is an ideal for the feature extraction. After training our model with the help of processed data, we saved the model to an HDF file. For a further processing, we use TensorFlow Lite, which is an open source deep learning framework on the device inference by Google. We converted our save model to TF Lite file, which is a compressed flat buffer model. We developed an Android app using TensorFlow Lite, which can classify the category of birds using camera mobile device in real time. Android application take less than 2 seconds to detect a bird and show the result with confidence score and the index of bird category.